this is a project. Yeah, this is a project about microbiomes in microalgae as a natural source for the prevention and treatment of diseases in aquaculture. So this presentation will be given by Sarah Leun. She is the vice coordinator of the project from the Technical University of Hamburg in Germany. And you probably also see this in your screen. So for this Flash project presentations, this meeting is recorded. So please, Sarah, you have the floor.
Yeah, hello, welcome. Can you hear me?
Yes, perfect.
Perfect, okay. So then I will start my presentation. Okay, yeah, thank you, Martin, for the nice introduction. Yeah, my name is Sarah Leun. I'm working at the Hamburg University of Technology, and I'm the vice coordinator of the project. And we are working together with the Sea and Sun technology from, for example, Stefan Hindersien, who gave the presentation at the beginning, then SINTEF, the University of Hamburg, 2 departments from the Aalborg University, and us. And yeah, first of all, I would like to give a short introduction about the objective and the structure of our project, and then I will go more into detail about the relevant work packages and how we address yeah, topics that are interesting for this workshop. So first of all, I think all of you know that microalgae have a really promising potential to be yeah, sustainable resource for products. And some or many microalgae were already shown to have a bioactive effect on pathogenic bacteria, for example, or viruses. And microalgae are generally not axenic, but they normally have a microbiome. So not like Stefan told before, but if you go into large-scale cultivation, you always have a microbiome surrounded by the bacteria. And this microbiome is also quite interesting to have a look at. And in the aquacultures, pathogenic bacteria are a major problem for the production process. And we are trying to find bioactive components from microalgae that have a health promoting effect on aquacultures as a precautionary treatment. So normally antibiotics, for example, are used, and we try to go somehow back to nature and try to set up the link again between aquacultures and microalgae. You can see here the structure of our project. It starts in smaller scale by exploring microalgae microbiomes and new resources. And then there will be the usage of omics technologies to get a specific view on characteristics of bioactives, for example, and a functional screening of different microalgae. And then the part that is important for this workshop will be the scale up and the processing of the microalgae. So in work package 4, there are different microalgae screened, and some of them are selected. And all this is accompanied by the prospective technology assessment. Okay, so going a bit more into detail about the work package 5, it starts with the scale up. So for this year, we already selected the first microalgae, and every microalgae has its specific parameters of growth and also yeah, somehow a system that it's likely to grow in. We at the Hamburg University of Technology have different systems here, which are the general ones, as Stefan said before. It's a tubular reactor, flat panel airlift reactors, and an open pond. And we started with a scale up in 10 liter and got up to 6,000 liters in the open pond. During all this process, we monitored the productivity of the microalgae and also, which will be done by our partners, the bioactivity, if it's still there, because if you can imagine, outside an outdoor cultivation, even open, might have some contamination risk. So it might be that this bioactivity, which was shown at the beginning, might not be there at the end. Also, the cellular composition is monitored over the whole time, and also the composition of the microbiome. Then in the next step, which is done parallel, it's the downstream processing. So every downstream processing step has different technologies that are used or that can be used. which are mainly dependent on the product that you would like to have and also the type of microalgae, because you might have a different, a very strong cell wall and you need a larger or a better cell disruption. And also the drying process, which has high temperatures, depends on the product that you would like to have. So in the project, we tried, or we are examining different steps and different technologies at every step, and also taking up the energy consumption, the water consumption, the productivity, the biomass loss, and so on. And all these data will be one part of the technology assessment, the prospective technology assessment, which is done by the Department of Planning of the Aalborg University, and which first defines the functional properties of the AQUAHEALTH project, which is at this point quite difficult because now, for now, we don't know the final product, but our data will be the base for the comparative life cycle assessment. And there we are working really strong together with Sea and Sun Technology and all the other partners from University of Hamburg and SINTEF and the other department from Aalborg University to get this comparative life cycle assessment and to develop different scenarios for our final product. Yeah, with this, I'm at the end. I already exceeded the 5 minutes that were requested. Thank you very much for the attention, and we are all open for questions because many of my partners are here as well today.